this lecture we will learn about basically how the computer works and focus on what is relevant for writing efficient C. We will also look at how a compiler can, how it translates the program to machine code, but how this machine code is organized. For instance, to make a loop, to make a stack frame when you call a new function, etc. Okay, so first two words, computer organization and computer architecture. These are newly invented definitions, and it's basically what this means. So computer organization, that's usually the first book you read about this, and then computer architecture, the second book about how to make computers more efficient. So it's the first one is more a generic view of the components and how they work for all computers. And computer architecture, it is inventions since decades how to make the machine efficient. But as we will come to when we look at the first family of computers in the sense computer architecture, that's the IBM 360 from the 1960s. It's also a machine specification which makes new generations of different products compatible. For instance, x86 is an computer architecture. ARM is another. Power is yet another. So computer architecture is used in two different senses. It's a compatible product family and ideas how to make a fast computer. Okay, so let's start with what we will learn about. So we need to learn about the CPU, and not in this lecture, but in the next about hardware, we will see how they are made to be very efficient. We will learn about memory. We will not learn about hard disks or network interfaces or keyboards or displays, but we will learn about software, how that is executed on the machine. So what we will do in more in this versus in other courses, we will learn how slow memories are and techniques to make them faster. Well, not make them faster, but to make them appear faster. That's cache memories. And if you want to learn more about disks and file systems, then you should take the operating systems course. There is something extremely important called virtual memory, and that is a trick invented in the late 1950s, how to make a computer appear to have more memory than it actually has, appear to programs and programmers to have more memory than it actually has. And virtual memory is also used to protect different programs, running programs, from each other. Maybe I will talk a little about that, but not very much. Just to get I will, but to get into the details, you should also take the operating system course, which is a very good course, and almost it should be compulsory for all computer engineering students, in my opinion. Okay, so in this part of the course, we will learn about the CPU or processor, memory hierarchy, registers, cache memories, and main memory. And swap, that's when the program's memory does not fit into the ROM, it's put on the disk in an area on the disk called swap area, and then software. So what does a processor consist of? It consists of various units which can do different things, such as adding and doing arithmetic, doing comparisons, and jump to a different function. In the program. Then we need registers, and there are typically three kinds of registers: integer registers, floating point registers, and simmed registers. A floating point register can contain a float or double. Integer registers contain the integers, obviously, and the simmed registers, they are like short vectors of 4 ints, for instance, and they are interpreted differently depending on the command that the CPU should perform, meaning they can contain either integers or floating point numbers. Then there is an extremely important register called the program counter, and that's a register which contains the address of the next instruction to fetch and execute. So what can a processor do? That depends on which kind or type of processor. If it's a RISC processor, such as what you have in your mobile phone, then it can do these things and a little bit more. Meaning it can read from memory and copy that data to a register, or the other way around, to write from a register to a memory, do arithmetic, and do a branch. There are more complicated kinds of processors, such as x86, which can do many more things.